as I said, the point of this lesson is just to kind of teach you what revolves are. Okay, so if you do a simple Google search in the images area of the word Solidworks Revolve, you'll get all kinds of evidence of what a revolve is. Okay, and we can use it for a number of things. If you take a look at this candlestick, okay, with the exception of the handle, you guys hopefully are looking at the screen at this point. With the exception of the handle, this is a symmetrical part and it's spun. This handle is done with what they call a sweep, and we're going to learn about that after we learn about revolves. Okay, so take a look at this shape. Okay, this is spun around a center line, and then we have the profile that creates that interesting shape. Here's an example of a wheel rim. So we can easily make this, and that's probably what I'll recommend that some of you do for an example. Okay, obviously a chalice or some sort of cup, right? Another example, a wine glass, right? That was done in SolidWorks and rendered. That was done in SolidWorks. That probably took 45 minutes to render. And we'll talk about photorealistic rendering coming up as well. Okay. Here's another revolve of something of mechanical design. I'm not sure what it is, but something for a machine. Let's go down and do one more example. Here's a simple one. People ask me, like, how do you make a cone? Or someone asked me earlier today, how do you make a sphere? It's the same principles that are applied. A cone or a sphere or a rim or a wine glass all does the same thing. So let's cut to the chase and actually do it. So if you want to try to participate while I'm giving this, you can try. For the sake of recording, going to kind of speed this up. The video will be available after I'm done talking, okay? So we're going to do a new part, just like any time we start something new, and this is strictly experimental. There's no purpose that this design is actually going to kind of perform. It doesn't really fit any purpose other than the sake of we're learning, okay? So once the part environment is established, the computer's running a little bit slower because I have the stream going on. So we're going to go to Features, and it's going to ask you, like, what is it you're going to be able to create? Okay, gentlemen? So right now, the only two things you can do are Extrude Boss Base, which you all know how to use at this point, and then the other thing that could be the base of your part is the Revolve. So we're going to click Revolve Boss Base, and then it's going to ask you which plane of which the sketch is going to belong on. We're just going to choose the front for now, because we're going to make a bottle. I'm going to choose a bottle as an example. Okay. So anything that deals with cylindrical relationships, center points, and things like that, it's nice to keep the center of things with the origin at the center, because you can always grab the origin and know you're at the center. Okay. So what I'm going to do is create a vertical line with the line tool, just vertically standing up from the origin. Okay, on the y-axis if you want to speak coordinates. Okay, so that's going to be our center of rotation. That's going to be our center line as well. Okay, now we're going to create a bottom. So we're just going to take another line and I'm going to shoot it out. All right, and then at this point, just for the sake of making a bottle, even though it's going to be kind of not smooth, we'll learn how to fix this later. We're going to make a little vertical section. Maybe this is where the majority of the volume of the liquid in the bottle is going to be held. And then we're going to taper it just we're freehand drawing. And then here's the neck and then the lip. Okay, so if we created something like this, what this is going to do is it's going to represent half of the bottle. Okay, so if we were to look at the whole bottle profile, right, the silhouette of a bottle, this is like vertically cut down at the line of symmetry. This is half of the bottle, right? I didn't draw the left side because it's symmetrical to the right side. And this could be a wheel rim profile. This could be that wine glass that we just looked at. This could be, for someone that asked me about the sphere today, this can be a circle cut in half. This could be a half of a circle, and then we'll get a sphere. It could be half of an ellipse, and then we'll get an egg, right? So if you get your shape and it's an enclosed shape, you're going to click the confirm. And now I have no dimensions on this because, once again, this is not tied to any shape or size. I'm just trying to demonstrate the principle. So if this needed to be a bottle that was like 6 inches tall, we would have to smart dimension this being, 6 inches, right? So now I have a 6-inch tall whatever. Prior to me defining it, it would be undefined. It would be like, it could be 6 miles big, right? So anyway, we're going to confirm with the blue arrow, and because I chose Revolve and I didn't skip out of this process, the next question it asks me is like, what are the parameters of which I want to spin this around at? If it's a bottle, it's going all the way around, right? Maybe we're making Pac-Man, and we only want it to go 270 degrees around, so it looks like his mouth is open. I'll do that next. But axis of revolution, it's blue. Let me close my magnifier. The reason why it's blue is it's asking you a question. It means it wants you to click on something. And when you click on that something, it's going to go into that blue field. So we're going to click this vertical line. And as soon as you do, it's going to show you a 3-dimensional revolution of that 2-dimensional profile. Right? Obviously, this is a very good bottle. I understand that. But we're going to say OK. And your shape is going to be a little different than my shape because I didn't give you any numbers. Okay? Now, remember, we learned something earlier that we could make this a vessel to hold liquid. My question to you, what would we do that we would hollow this out? What operation have you done before that hollows things? Shell, right? I heard that. Very good. So one last thing. This is going to be a bottle, so I want the top to be gone. So if I want to shell this with the top being gone, what do I have to click on before I shell it? What do I have to click on? Someone help me out. Anyone? What do we have to do on the front of our CD storage container so that the front disappeared before we shelled it? 1 centimeter. Remember? We had to click on something and then that something disappeared. Right? We clicked on the front. Right? And then the front disappeared. So if I want to make this bottle with the top open, what do I click on? The top. Right. So we're going to click on the top here. And all you're going to do is click shell. And when you click shell, it's going to ask you like how thick of the walls you want to make it. 1/10 of an inch if you're using inches is more than enough. 2 millimeters is fine if you're in the metric system. I'm just going to say OK. And now the top is gone. My bottle is hollow. And one last thing I'm going to show is let's cut this in half and see it. So click section. This is being recorded. And you're going to say OK. And once you do that, you have a section view of the bottle. This is proof that your object is hollow. Okay? So I'm going to redo that one last time. I'm going to click the section view. And when it asks you what section do you want to section, you'll click the front view. And then you can kind of click and drag this. Okay? If I shut this off, I can do the other plane. If I click X, I can click the right plane, and now it's going this way, right? One last thing, if I were to show you how a 3D printer works, and we've never talked about it before, I would probably choose the top plane and click section view and explain to you, if I were to print this bottle upside down on the 3D printer, this is what it would look like. Right? Layer by layer, it grows, it grows, it grows, and then it makes the roof. Okay? So you just select a plane of choice and select the cross section, and you can prove it to me and yourself that the thing you made was hollow. Okay? So that kind of concludes how the Revolve operation works. And so I'm going to save this